Sorry about that, everyone. My video just turned off for some reason. Well, hello, everybody. Thank you for attending today's webinar, Automation, the Easier Button to Parcel Data Governance. My name is Amy, and I'm the Operations Manager here at National States Geographic Information Council. If you are unfamiliar with our organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like to learn more information on how to get involved with us, please visit our website, www.nsgic.org. Some reminders for our call today. All attendees have been muted on entrance. There will be time at the end of the presentation for Q&A, so please place your questions into the chat box and they will be answered and read aloud at the end of the presentation. Additionally, a recorded version of this webinar will be made available afterwards, so be on the lookout for that. And with that, I will now turn it over to the presenters. Thank you again for joining us.
Thanks, Amy. Well, good afternoon, everybody, and thanks for joining. I'm Sheila Stephenson, CEO for 1Spatial, Inc., and today with me is Melissa Alvarez, who is one of our crack solution engineers, and we want to share with you some thoughts around the process of governance for parcel data, because it's something that is near, well, number one, I'll say it's near and dear to my heart, because some of the first data that I began working with was in my geospatial career was parcel data. And I do know from those early days, the challenges all the way up to today, the challenges that still exist. As an example, when I think about a national parcel database and the fact that there is one, but it's a purchasable database. And what do we need to do to create and establish the governance required to be able to actually create an accessible national parcel database? And I think it really starts more down with the locals and can funnel to the states and then funnel from the states to the nation. But if it's a manual process, then that's just too overwhelming and actually probably just way too daunting. So Melissa, can you go to the first slide? Oops. All right, so first start out with a question. What is it that excites you about data? Now, you don't have to answer this, but just think about these things. Number one, is it the information that you get from the data when you examine the data and the information that you use to do your business or your work more efficiently and effectively? Or is it two? Is it, again, the way it makes business a much more efficient process and a more effective process, because with good data, we're able to make better decisions? Or is it three, my favorite, the cleaning and maintenance of data? As I said, you don't have to answer because kind of obvious, I think, at least, which would probably be your least favorite. Next slide. Thanks. So the statistics here, and this one comes from MIT, the first one on the left, is that employees spend 50% of their time just trying to deal with data quality. And probably part of that is understanding where the issues are, or if there are issues, and then also just how do we clean them up and do it in a manner that's not so daunting. And then this one on the left also was really concerning to me, because when you think about a data scientist's job, they're responsible for taking data and really doing some high-level analytics on it to, break new grounds and to discover new things. And if they have to spend 80% of their time cleaning or organizing the data, and I imagine some of that is finding the data too, then it's that means only 20% is really going to what their real day job is. Next slide.
I'm sorry, my mouse is really sticky.
Okay,
here we go.
No worries. So we need to start with a very good, solid data foundation. And obviously, parcels are one of the key components to that good data foundation. But there are challenges at every step of the way. As I mentioned, there's creation of data. I mentioned very early on, I was actually building parcel databases using coordinate geometry and inputting meets and bounds. That was a heavy lift. And then a lot of the time, the deeds were really, really old. And so the surveyors just weren't that accurate, we'll put it that way. It was quite often that I would find things that didn't close properly, parcels that didn't close properly, and or things that actually just created what I called a squiggly line. So the creation of data is, but fortunately, we're in a better spot today with regards to data existence, but we still do need to create some data. And we think about LiDAR extracted features, we create those, and then they come across as very jagged, and then we need to deal with improving the quality of those. And accuracy of the data, as I mentioned, there's data that goes way, way back, and then we get new data, like LiDAR extracted features, which is going to be much more accurate. But then we have all the historical information in the old data, but it's not probably as spatially accurate as the new data, and the new data doesn't have all that rich history. So accuracy is definitely one of the data foundation challenges. And lastly, there's maintenance. So, oftentimes you might hear about people sending their data out to be cleaned, and, outsourcing it, and then they get the data delivered back. But the moment that data is delivered, what happens if you don't have a maintenance workflow process? And again, trying to maintain it manually, especially if you look at some of the larger cities or at a state level or larger counties, it becomes, again, much too daunting of a process to try to keep up with. Next slide, Melissa. So good news is that's what we focus on. We really focus on ensuring that data foundations are quality, and they are accurate, and they are more easily to create, and also establishing those workflows, those automated workflow processes that enable the maintenance of the data ongoing. And it's based not on just what you might consider geospatial checks or what have you. It's really business rules. What must the data do to be correct, so that when it's used to make decisions, it will give the right answers? And so, as you can see, even though we really only I took over 1Spatial 7 years ago. And at that point, we had one client, and I'll talk about that in a minute. But now today, we have somewhere in the neighborhood of 40 to 50. And we are in all levels of government. So you can see the federal, we have census still, and USGS, and then Federal Highways Administration. A lot of work in transportation because they have very complex data to deal with, as well as in state spatial data infrastructures. And we'll talk a little bit about the one we have implemented for Michigan. And there's also another one we're working with Arizona. And so we have quite a bit going on with that data flow, what I like to call the flow up from the locals to the states. And I'd like to argue also that then that same data could flow into the national to help us establish our national spatial data infrastructure. Again, utilizing automation to enable this to be a manageable process. And the last thing I'll say is that it doesn't matter what kind of data you're dealing with. It doesn't matter if it's spatial data or non-spatial data, CAD, computer-aided drafting data, or asset management systems like what we do validations for Google and their real estate worldwide services. So we're data agnostic and also format agnostic, and we're able to then pull this data in and validate it and ensure that it will meet your business needs. And we do this utilizing our One Integrate and One Data Gateway products, which Melissa will be sharing more information on in a bit. So I like this because I think it really does represent the way most people feel about a data foundation, is that, it's very important. It's at the top of importance because we need a good solid data foundation to make all kinds of critical decisions, whether it's in a 911 space, whether it's planning, whether it's for a large organization like Google, trying to determine if they need more building space or less. But then I think most people would also agree that it feels hard for all the reasons that we've already talked about, the challenges that you're faced with in trying to establish and keep a good solid data foundation. But with our One Integrate and One Data Gateway solution, we want to click Miss Melissa. We like to say that we still put the import on it. It's still at the top of the list as far as the importance, but it also can be found to be much easier in order to manage and to establish a good solid foundation, and then also to maintain the foundation using automation. So, and earlier I mentioned our first client that was over here when I first joined with 1Spatial. And we were in the process of that point of establishing the spatial data infrastructure for the US Census for their Math Tiger. And for those of you who may not have been working with data quite as long as I have, the Math Tiger is a census provided database that is public, and it is the master address file and the road center line for the entire US and then some. And the way it got updated historically was taking in data from some 3,200 different data providers, and it was a mostly manual process. So if you can imagine trying to keep a national database up to date from all this data coming from all these different directions, then, you know, that is a huge undertaking. And of course, they were never up to date fully because you just couldn't stay on top of that. I can't imagine the number of bodies that you'd need to throw at that in order to handle it. So what we implemented for them was this automated workflow process that basically, as the data is delivered to the US Census, the first thing that happens, it's QA/QC'd through the rules validation in the engine to make sure it's going to meet the census requirements. Once it passes that, it goes through an automated schema mapping. And once the schema mapping is established, the engine performs an automated change detection. What is new in this submission from what is already existing in the current Math Tiger? And the purpose of that, obviously, is so that you just deal with the changes. You don't have to look at a rip and replace of the data every time, or you don't have to look at dealing with the processing time that would also take to deal with going through all of those different changes versus non-changes. And then finally, once it establishes the differences, the system goes through and establishes what we call proposals. And it's basically, what should we do with this change? Is it an addition? Is it a deletion? Is it a scalar or an attribute change? And it will then do a number of confidence checks to determine exactly, does it meet the confidence level established by the census to automatically ingest the data? And if it does, it gets automatically ingested. If it doesn't, it then goes through what we call a semi-automatic review process, where an individual simply steps through each one of the proposals that didn't quite meet the confidence level and either says yes or no. Yes is going to automated ingestion, meaning yes, that proposal is correct. No's go for further update into the database. Next slide. Thank you. And so as you can see that to date, they are now 90% automated. And this isn't us saying that, this is what the US Census has said to us. And they've gained a lot of improvements or benefits out of this process. And I think one of the most significant one is the last one on this list, which it really did help reduce the extent and cost of the address canvassing that they had to do for the 2020. And I've had discussions with them, and they're looking at more ways to automate more things so that for the 2030 decennial census, they may not have to send anybody out into the field, which I just think would be phenomenal. Because when you think about it, think about what happened in the 2020 census. COVID came around, and sometimes there are emergencies that happen, and all those things can affect the work that the census has to do. And a matter of fact, due to COVID, some of the census work had to be delayed. And so I just think the idea of being able to automate to save so much time, and not to mention not just the time, but the cost. And when they did analysis on the 2020, by automating it, they significantly had some very significant savings there. So we were one part of it, and I'm pretty proud of that. And I think that we can all consider that anytime we turn a largely manual process into a mostly automated one, there's going to be great gains. Next slide. So next spatial data infrastructure example is work we have done with Michigan for their Michigan geographic framework. They had this spatial data infrastructure basically in place, but it had been established for a number of years, and it really needed to be modernized or needed a refresher. And so we worked with Michigan to establish the workflow. Again, they saw what was done for census and realized, why couldn't that be done for us? And so we worked with them on the ingestion of the data from all their state and local providers, and to go through a similar process that the census did. And again, gaining the same types of benefits that you might normally see from the spatial data infrastructure automation. And next slide. And what's really interesting is part of the way through the implementation of the Michigan Geo Framework, we started talking with them about their efforts around the next generation 911, and had discussions about how we could really implement a very similar system to what the MGF had, and then tie those two together. So for the slight difference in the 911 side of the house is there's an added benefit for the data providers in that when the local emergency data managers submit the data in, the first thing that happens is it's validated, and then the locals receive a spatial report back that shows them, because it's validated against the very specific NENA NG911 validation rules, and it identifies exact location and issue or rule that the data was validating, or didn't validate to, or was an anomaly. And so they're able to then much more easily, very similar to the way the US Census would go through and just look at one and say, okay, this is what's proposed, how do I fix it? They're able to look at it and see what the problem was, and then go in and fix it. And then once they got the validation to meet the requirements, then it went in for submission, where automated change detection occurs again, change proposals, then pushed into the NG911 database. And an added benefit out of that, again, was that those locals, data providers that approved the push of their data into the overarching statewide MGF, they were able to then take that data into and further enhance the MGF spatial data infrastructure side of the house. Next slide. Thanks. So they really received, or receiving, I'd say, benefits on both sides of the house, because obviously the process being automated and less manual intervention is going to lead to higher data quality, the review of the rules and ensuring that the rules were producing the right results. Again, will ensure that the data that is being used by so many different people will be accurate and reliable. And again, it will reduce costs through efficiencies. And really the bottom line is, when we think about it, when you think back to those percentage slides I presented earlier on, a key component of this is freeing people up to do what their day job is. So to really focus, in the case of Michigan, on the mission of the state. And if you'll hit click again, and then again, similar on the 911 side, because a lot of those emergency data providers, they are not GIS experts. They're not, they aren't skilled in the way a lot of us are. And so the more easily we can help them identify and correct the issues, the better off for everybody, and the more rapidly that data will become reliable, and especially because it's the most critical decisions are made utilizing the NG911 data. And then the added value going back to MGF to extend additional data into that overarching statewide database has really enhanced it as well. And so on the 911 side, that was a great implementation, but there's more. So what that implementation and one or two others like it led to is a truly repeatable solution that follows those same processes of allowing the 911 data providers to push their data up to a state level and have it validated, get the information back as to where they need to clean it, and then go and submit it in for the statewide 911 database. And you see a number of the different entities that we work with and are growing. There's others as well. And I would say that it has improved and become such a repeatable solution that we now can implement or stand it up and get it into the hands of the locals within a 3 and generally no more than 6 month time frame, which compared to what it used to take to stand up a solution for emergency services data is quite more efficient, we'll put it that way, and obviously becomes more effective sooner rather than later. All right, Melissa. But, you know, 911 is one use case, and obviously parcels are now coming into looking at being a more valuable part of 911. But I hate unitaskers. I don't know if you know who Alton Brown is, but he rants, and you should look at it because he's hilarious, on unitaskers. And if you don't know what a unitasker is, it's those things in your kitchen drawer that drive you nuts because they clutter it up so much you can't find what you really need. And they only do usually one thing. So I use the example of a strawberry huller, although I know Natalie from Georgia says, no, but I love my strawberry huller. Well, Kevin looked at her and said, Kevin with 1Spatial said, well, I have one of those too. It's called a knife. So we want things that can do more than one job, and we need to do that because we have to be more, again, efficient, do more with less, those sort of things. So the One Integrate rules engine, when implemented for one solution, is definitely a multitasker and can be utilized for a wide variety of other solutions. As the example in Michigan, where it was used to start with the spatial data infrastructure for the state and then expanded into use case for the NG911. And then we have other states that we're working with that started utilizing it for next generation 911, but then they're expanding to use it to help support some of their other state agencies like DOTs or planning departments or what have you. Next slide. So, like I said, we're focusing on parcel data today, and parcel data is very important. Obviously, it is one of the key foundations, but it's not to negate that these other layers aren't important as well. And what I would say is that the One Integrate solution is such a repeatable solution. Boundaries are boundaries. So parcel data is one area that needs to be validated and integrated, but all of these others need that too. And by tweaking the rules to fit those particular layers, you can use a very similar pattern and again, expand to cover all of these different types of data. So definitely not a unitasker, even though we will focus in on parcel data today, like I said, because it is such an important layer in our data foundation. So now I'm going to pass it over to Melissa and let her pick up from here. There you go.
Alrighty. Thank you, Sheila.
Mhm.
And I hope you guys don't mind I turn off my video. I don't think you want to see me coughing. So So like Sheila said, our focus today is on parcel data. And so what I like to discuss in this part of it is how our multitasker tool, which is One Data Gateway, can actually be used for managing parcel data supply chains. And I want everybody to keep in mind, I might be saying we, but really what I mean is what our customers are actually doing. And so one of the things that started off this, the creation of this solution is our customers are coming up to us and saying they inherently trust their data, and what they're actually ready to do is say, here are my parcel data, what else can I do with it? But we always take a step back and say, well, we have what we call our essential geometry checks on hand here, and we do also provide them with that rules package. And what we want to do is say, foundationally, is our data correct? Is it clean? And it's a little surprising that a lot of our customers are actually caught off guard with the underlying topological errors that actually exist within their data, within their parcels. So the step that we want to start this data supply chain with is running validation workflows. So for parcel geometries, we want to run those essential geometry checks, be able to find those gaps, overlaps, spikes, kickbacks, etc. And then after, as we're checking the geometric cleanliness of our data, we also want to make sure that the attribute checks or the attribution is correct. If there are any business rules in place that our customers have, they want to write rules or they write rules that say, here's how my local data looks like, and I wanted to match my local domain checks, for example, or my local domain table values. And then once they have the parcel data clean, as clean as they can get it, one of the other things that our customers have done is also say, okay, now that it's clean, can we actually leverage this this clean data set to be used in other features? So in here, one of the most common things that we've integrated within One Data Gateway is the use of address points that are expected to be contained within parcels. And then if our customer also has building footprints on hand, we go ahead and say, hey, what can we do for these address points that we can improve their spatial location by finding a matching building footprint within the same containing parcel. So a bunch of that stuff that I just mentioned are validations that are that sound easy, but they actually are not easy. And to even add on to that, the foundational checks or the data foundation challenges that Sheila was mentioning, we also encounter we also encounter parcel data that exist in separate systems, and yet somehow they are equally accurate within their own database silos. So this is the case that we commonly see between an organization's GIS department versus a tax assessor's office. So what we're comparing here between the two different data silos is that we have parcel geometries versus parcel records in a flat CAMA or computer-assisted mass appraisal table. Now, luckily, as Sheila mentioned, our multitasker, which is One Data Gateway, is data agnostic. So the parcel data supply chain that our customers want to do would like to use for their SDI to benefit is to include those cross-system validations between the two sources and ensure that the records are complete, first and foremost. And then if property information that's sitting in that CAMA table is accurately reflected in the feature attribution table. And so really what they want to be able to capture here is the synchronization of the flat parcel information plus the parcel data on the GIS side to be used for perhaps publicly used property maps that's shared with the public. So looking at this cross-system validation more closely, how do our customers actually want that set up? So in my example here, the CAMAS table exists in a CSV file, but it can also be a table sitting in an enterprise database. So on the right-hand side, an organization's parcel polygons can be stored as a shapefile. And again, it could be sitting in a file G database or Postgres or what have you. The point here being that our customers can configure a multitasker tool to pull in these different data formats to run within the same validation workflow against the same data quality standards. And so let's take a look at how this would look like from the perspective of a one data gateway user. And let me go ahead and switch gears here. So hopefully you're seeing my screen correctly or clearly. So where we're at now is One Data Gateway. It is a self-service web-based portal that performs data validation, processing, and enhancement. So I'm going to go ahead and log in as a let's say a county representative, and this One Data Gateway instance has been set up and hosted by the state. So even if this is my example, I do want to clarify that one of the other options that we offer is we can provide a validation as a service for your parcel data sets. So it really doesn't, we have a lot of options on how you want this environment to be hosted. We can definitely work with your needs on that. So again, I'm going to go ahead and log in as a county user. And let's say that my state has hosted One Data Gateway, and they're telling me that for me to submit your parcel data to them, I have these validation workflows available to me. So on my assignments tab, which is where we're at right now, I am presented with various workflows to use for my parcel data. So I can run attribute validations for my CAMA table. I can also run attribute checks on just my parcel GIS. For the parcel GIS, I can also run essential geometry checks for those spatial to spot those spatial errors, as well as gaps and overlaps. When I get those clean, I can also go ahead and say, let's take a look at my site structure address points and building footprints and see how we can leverage our clean parcel data set with that. But what I really want to look at here is the parcel GIS versus CAMA. Excuse me. So the way that this workflow has been set up in particular is for me to submit either a CAMA table or a GS parcel or both. And what I want to highlight here is, again, it's another function of configurability on the end, on the end of the customer, of the person who's actually using this environment. And so one of the examples I can give here is, let's say, what if the state on the back end, they actually have the option to wire up a connection to the current CAMA table, so that maybe all I have to do as a county contributor is to submit my parcel polygons. So for this demonstration, again, I'm just going to go ahead and go ahead and submit both data sets from my end. I'm going to go ahead and click and drag, submit our parcel polygons and my CAMA CSV files. So now what's running behind the scenes is One Data Gateway is trying to map the schema for data submission. So wherever there is a one-to-one match between feature classes attributes, it will automatically map those across. Where it's unable to, I can actually go ahead and manually make that change using this drop-down menu right here. And we're seeing that among all of these different attributes that is asking for me, I was able to map parcel number across as a submitted PPN. And the reason why we already have this mapped across is because the first time that I ran this, I went ahead and saved my schema mapping. So I can go ahead and submit multiple versions of multiple schemas for my data. And what One Data Gateway will do is say, as long as my submitted data schema stays the same, whatever schema mapping I saved in here will be saved for next time. So that's exactly what we're seeing now. Everything mapped across perfectly, just like I did last time. And so I can just go ahead and hit continue. Excuse me. So what we're seeing right now is we are rolling through the cross-system validation. So we start off by loading our data sets in here. It's loading in our camera, it's loading in our parcels. And what we want to do before we even touch those cross-feature checks is validate our camera table on its own and validate our parcel GIS data on its own. And the reason why our customers like having these foundational rules is because, again, we want to make sure that each and every single record on both data sources actually exists. So if a parcel number is supposed to be a parcel number that exists within a within a camera table, the expectation there is that it exists on the GIS side as well. So if that parcel number value is null or it has an invalid invalid format. For example, if the expectation is that it's an integer that is 8 digits long, and for some reason it has alphanumeric data in it, all of that data we want to go ahead and say, let's put those aside and then run these cross feature checks between the ones where we do have matching parcel numbers. So before I go any further here, what I want to do is kind of help us through what these numbers are actually actually mean. So because these are rules, what we're looking for is rule conformance. So if we don't have 100% here, it means we have rules, we have features in the data set that are not conforming to the rules. So in here, we only have 99.95% of our parcel camera table that passed our checks saying that the parcel number is not null and that the parcel number is valid, as in it is in the expected data format. So now let's roll through some of the examples of cross-system checks that we have here. So again, one of the main concerns between these two data sets is that are our records complete? Are we sure that we have matching records across? So in here, we have a rule that says check that each parcel boundary has a camera record. And vice versa, each camera record has a matching parcel. And of course, if we have missing records between the two, of course, you know, how do I say this? The implication of that on the tax assessor's office is not good. Let's just put it that way. And ideally also, because this is parcel data, we want each and every single attribute, each and every single information in there actually match up. So just as an example here, we are saying that on the camera side where we have the same parcel number, do our grantee and grantor names match up? Lastly, and I really like this check, where we check the camera parcel area actually matches a calculated parcel GIS area. So what we're doing here is there is an attribute on the camera side that says this is how big the parcel lot is versus the actual calculated geometric parcel area. And I'm going to explain a little bit more on that when we take a look at our results. But what we want to do here is hit continue. Because I want to show you how a customer can download the results from these validation issues. So I can go ahead and download my table markups as well as a spatial markup, spatial report for my parcel polygons. And before we take a look at what those outputs look like, I want to point out this this neat auto-generated PDF report here as well, where it essentially shows us the reports on our data. It is a copy essentially of the data submission, and it details how many camera records and parcel polygons were checked, what are the metrics that came out on these rule conformances, and at the end of it all, what are the output results that were produced. So let's go ahead and take a look at how this looks like within a GIS application or perhaps an editing environment for your GIS. So I do want to mention, I didn't run all these validations live, all the validations that I mentioned, but I did run all of the workflows beforehand. So before we jump to the CAMA versus GIS parcel results, I want to start with the more basic validation results. So I have here some examples of geometric issues that are found in parcel polygons. And that's what you're seeing here right now with these teardrops in here. And these are the kind of data quality issues that have the potential to cause increasingly complex errors as a customer's parcel data makes its way through the data supply chain. So one of the very real applications of this is that we do have customers that want to use their parcels to align other boundary data layers. So of course, before we use our parcels as a foundation for that boundary alignment, we want to make sure that we have issues that look like spikes, as in this parcel spike right here, issues where we have overlapping parcels, as well as gaps in our parcels, making sure that these are addressed before we even think about data alignment with other layers. And also notice how these reports are spatial and navigable. They can be configured to include as much information as one really needs them to be. So if I select this, and I think we kept this very simple. Right now, we're just saying what is the class that I am reporting on, and what is the comment or the rule that was violated by this object. Excuse me. All right. And so let's check on some other some of our other validations here. Oh, so I'm going to go ahead and bring in some additional data. Let's take a look at our address points first. So let's say that now that our parcels have updated or have been cleaned, let's go ahead and cross-check that with address points. And so what we're seeing here is we got flagged for an address point not matching a parcel, and that's because the address point has the address as 7836 versus the parcel polygon, which has the address as 7808. Oops, I wonder what that is. Okay. And let's leverage the data even further, because let's say that some of our customers do have building footprints on hand. And one of the things you could do here is say, if an address point is within a parcel and there's a building in it, the expectation for that is for that address point to actually be within that building footprint. So we're seeing here that these two markups, or these two address points right here, have failed a cross-check saying that this address point should be contained within a building. Okay, so moving on now to results of what we were actually looking at on our One Data Gateway side. Let's take a look at some of the non-conformances here. So the flag here, or the non-conformance here, is it says that each parcel boundary should have a camera record. So what I did here is essentially join the tables between the parcel boundaries and the camera table. And we're seeing here that with this pin on the parcel boundary side, we cannot find a matching record for that on the camera side. Another example here, grantee grantor did not match. And for this specific example, reporting example, we did go ahead and say, let's go ahead and report on what the two conflicting values are, so I can have an easier way to verify that this is a true non-conformance to my data. So on the CAMA side, we are reporting the grantee is Snyder, Gerald R. But on the parcel polygon side, the grantee is Snyder, Gerard R. And the difference there is the L and the R on that first name. We're seeing here that we have a confidence of 1, and that's because one of the things that we can do is, or that our customers have actually asked us to help them with, is to allow a slight difference in string by assigning match confidence scores. So this in particular is called Levenshtein distance, saying that the difference between these two string values is just one character. So that's why we're seeing a confidence of 1. It's just another example of how we can configure the rules to fit customer data needs. Let's take a look at another example. And this is where a CAMA parcel area does not match an actual calculated parcel area. So one of the reasons why our customer wanted this check is because what they really wanted to find is any dramatic changes between values. So obviously the parcel lot size is a pretty significant detail in there for our parcel data between the two sources. So what we want to make sure is none of these are dramatically changed between the two. The way that we had written this also is they had a business rule that said allow a 5% buffer, plus or minus between these two calculated numbers, and let's call it a match if it fits that that tolerance. But in here, I have an example. The example that we're looking at is that on the CAMA side, the declared parcel lot size is 3,360, but the actual parcel area calculated is essentially twice that. So these are the types of data non-conformance between the two that our customers definitely wanted to flag and have to verify. All right, so I'm going to go ahead and go back to our slide deck here.
And Melissa, I'm going to point out the criticality of that because,
yes,
if you are, if it really is the larger number, then and you've got it listed as the smaller number, the tax dollars are being lost.
Exactly.
And the vice versa of that is that tax dollars are being overcharged, which is no fun for anybody.
Exactly. It really messes up the assessment there, which is the key, which is really the reason why we have that this information in the tax assessor's office, right? Okay, so moving on, I'm going to next kind of quickly talk about a process called change detection as part of a parcel data supply chain. Change detection really involves the comparison of two vintages of a data set, where we classify the differences between the two and proposing how these differences can be reconciled. And Sheila has already mentioned how we apply this with census, how we apply this in NG 911. And one of the things that I want to explain here is the way that we also have applied it on the parcel data supply chain for our customers. So this process typically occurs in the background when a county, for example, is ready to submit an updated parcel data set to the state. To illustrate what change detection looks like in the context of parcels, I'm going to switch gears again, sorry to confuse people, to our GS application. So we can go ahead and visualize what this process actually looks like. So, okay, we're seeing gray parcels in here that we want to update to our blue parcels. And if we turn on our reported changes by type, we're seeing that most of them are orange, meaning that they actually match up pretty well. So how about we go ahead and take these matches out of the picture and take a look at the leftover changes that need to be addressed. So got an example here, pretty straightforward. It wasn't there before, it was there before, it does not exist anymore, so we want to go ahead and delete it. In this example, we have parcels that have been dissolved, and now the proposals here are saying, let me just do that really quickly, is to go ahead and delete the parcels that have been dissolved and go ahead and add those two big chunks of the parcels. Another example here is where we observed a spatial change. And the reason why these have been marked up is because on the parcel side, or obviously on the parcel side, the shared edge actually shifted. So that's why we are proposing a spatial change between the two parcels. Last example here, where scalar change, because obviously customers are also concerned not just with the geometric relationships. We also want to see the scalar or the attribute relationship. What we're seeing here is a scalar proposal has been proposed because initially our two parcels in here had different parcel numbers. They have been updated to actually have the same parcel numbers. So that's one of the examples of how we can identify an attribute change in the data. So again, these results are typically produced behind the scenes as locals submit their data to be integrated into the state's database repository. So really what we just looked at is from the state's perspective. And so speaking of the state's perspective, going back to our multitasker tool of One Data Gateway, I want to go ahead and, I can't see I'm sorry, I can't see them right here. I'm going to go ahead and sign in as an admin user. So a state admin user has the ability to see who's using the system and how they're using it. And by the way, what I want to show you here is actually that I know that my example is that I am a county and this is a state hosted environment. But obviously, again, if we pick a different offering, the admin does not have to be the state. It can be anybody who is seen fit to have admin privileges. So I want to go ahead and take a look at the dashboard here because this is one of the neat things that a state can use, for example, to kind of have on hand on the data usage of their one data gateway environments. So we're seeing which workflows are seeing a lot of usage, how frequent are these users validating their data. And what this means is that this global access translates to information that can be used for BI or business intelligence apps. And we actually do have customers who access One Data Gateway's REST API and integrated with other systems like Tableau. Another example, again, of how this multitasker tool can help customize and enhance assessment results further. On a workflow level, I'm going to do this really quickly. I know we're running out of time. Let's take a look at the Parcel GS versus Kama. On a workflow level, we can visualize all the data contributor activity as a whole, top violated rules, how many submissions are being done throughout the day, and data conformance trends over time. So a state user or an admin user can also run the same validation workflows as its counties or its data contributors. It can also submit data on behalf of some users. So let's say that as an admin user, what if a county required some help getting their data pass certain validation rules? Well, we can also build a workflow that can automatically cleanse and correct data. And that's the example that I have in here, where I, as a state representative, can make a submission on behalf of a county called Wayne. I'm not going to run this anymore, but what I want to show here is a previous run where we're saying,
Melissa, we're going to have to wrap up pretty quick.
Yes, but we're saying that we have an address point here. Go ahead and fix as much as we can. Visually, we're seeing that it did work because we bumped up our conformance rate from 61.36 to 83.57%. And so let me go back to our slides here. Essentially, what I wanted to show here is that we are that customers want to find issues in their data, but also would like to have automated cleansing with it. Because again, we're not just finding the data issues, we want to be able to address them. And so just to wrap up, did you want to go ahead and wrap up?
Yeah, I think we want to wrap up. This is just a picture of what these portals look like, very similar to what we talked about before, but we only have 5 minutes in case anybody has any questions.
Yes, I'm really sorry I rambled again.
No worries. So Amy, do you see anything or?
I do not see anything in the chat, but we can give folks a minute to post their questions. Also, we do have Sheila and Melissa's contact information. So if anyone wants to directly email info@nsgic.org, I can. Oh, we have one question from Christina. How does the system handle condos or buildings overlapping multiple parcels?
Interesting. It will actually identify those. Those are one of the things that we can identify and then attempt to understand where does the address match, and it can make a proposal that it matches, or if it has both addresses in there, then you know that even though it shows a divided parcel, it's actually a single unit of a parcel, and that it will land on that right one. Does that answer your question? Or? And if you want, you can come off mute. I think, can they come off mute?
They should be able to. If anyone, I can, Christina, I can ask you to unmute if you're not allowed to. Oh.
So Jean, that's a great question. I see another one there from Jean about how do geometry checks differ from those used in Esri's Parcel fabric? And I'm not 100% positive on this myself because I'm not up to date on it. I know Kevin, I don't know if Kevin is on, but he certainly could probably answer that. And Melissa, do you know anything on that one? And if not, Jean, we will definitely get back to you.
Yes, we'll definitely get back to you. But I also did want to chime in to Christina's question there, where we can absolutely rewrite or configure the rules to take into account one-to-one, many-to-one, many-to-many, one-to-many types of matches between stacked address points, the possibility of having stacked address points, as well as stacked parcel data sets. So that's a short answer to that is yes, we can absolutely configure rules to take those into account.
Thank you, Melissa. So it's recommending to have the parcel boundary duplicated multiple times if there's like multiple condos or buildings or CAMA records. Exactly.
Hi, Christina. I don't know if you remember me. I'm sorry.
I do. I do.
Oh my gosh, how exciting. Okay, sorry.
I went through the training with 1Spatial with RIDOT and Rhode Island Department of Transportation quite a few years ago.
Nice to hear from you.
Yep, good to see you again too. Thank you.
So it looks like we have time for one more question, and it's from Greg. Lots and tax parcels can be different. A parcel can consist of multiple lots. How does one integrate deal with those cases?
Again, if you can put this into just like an English statement of what is acceptable in those cases, and if there is some way of identifying that those two are tied together and so they're actually like one, we certainly can deal with that. And Melissa, you want to add anything to that?
No, that was a perfect. I don't want to ramble anymore, just in case.
And Greg, I don't know who you're with, but if you would like to dig into that deeper, we'd be happy to spend a little time and show you at another time.
Yes.
All right. Well, it looks like it's at the top of the hour. I want to thank Sheila and Melissa again for this wonderful presentation and for everyone attending today. Sheila and Melissa, do you have any last words?
Yeah, I would just say, please feel free to reach out if any other questions come to mind, or if you just want to know. And Jean, I will reach back to you with someone who's got the more technical answer than what I would come up with. And anyway, appreciate everybody showing up today.
Yes, thank you very much.
Well, thank you to both of you once again, and thank you to everyone who joined us today. You guys, everyone enjoyed their afternoon.
Yeah. Thank you.